Now suppose we want to create a heat map like this, where we have the dendrogram. Well, we have in the heat map, each row is printed one after the other, right? And then we have the cluster dendrogram on this side, okay? And we want the shade, we want the grayscale for the values. Okay, larger the value, um, more dark. Okay, smaller value, okay, less dark. Okay, and then we have the predictor variables on the x-axis. So this is the heat map that we want to create, and that helps us understand the clusters. How closely the clusters are. Like so these two, and then as you go further along, how similar the different utilities or different rows are with respect to the predictor variables. Okay, and we need we're going to use heat map function. Okay, and we're going to use the normalized, okay, utilities normalized data set. All right, so now we want the cluster number with each of the row names. So that way, when you look at the heat map, okay, you would see not just the utility name, but then the cluster to which it belongs also is displayed. So right now, if you use the utilities.df.norm as is, you're going to get only the name of the utility. You're not going to get the cluster identity along with it. So what we're going to do is to change the row names, okay, to row names of utilities.df.norm, right? And what we want to do is to paste the cluster name in front of the row names from the previous row names, the row names that we have right now, right? So okay, the paste is like concatenate in Excel. So we paste what? Okay, we want to get the member.df and the cluster number is from there. Okay, and then we want a colon to be in between, and then the row names of utilities.df. Okay, now paste also includes a separator parameter, and we don't want any separator parameter, so we give two quotation marks with nothing in between. So when you run that, then you see here each utility now includes the cluster to which it belongs as a prefix. Then we specify the heat map parameters. So heat map, and heat map needs the data as a matrix. So you say as matrix utilities.df.norm. Okay. All right. So now if you run that, then this is what you'll get. So here you get a dendrograph for rows, and you get dendrograph for columns as well. But this doesn't make any sense because these are predictor variables, and we are not looking for clusters for predictor variables. So we want to get rid of that. Okay, so let's do that first. So that would be call V with the uppercase C, and you say don't want it NA, so then that's gone. So you still have the row dendrogram which you want. If you don't want that, then there is another option, ROLV. I mean ROV. Excuse me, take it back. ROWV, and you can suppress that as well. And then there is a H-cluster function. Okay, that is your horizontal, I mean a hierarchical clustering. That's the default, so we don't need to specify that. Then we can change the color here. Your textbook has color as the color equal to and quotation mark. So if you use gray 0, then everything is black, right? If you use gray 99, okay, so we need to close parenthesis, then gray 99, everything is white. So we want a scale going from gray 0, and our textbook uses gray 1 through gray 99. And we want, okay, right now if you do it that way, then gray 1 will be really dark, and that will be used for the lowest possible value. And then gray 99 will be white, and that will be used for the largest possible value for the distance. Okay, but we don't want, I mean, for the values of the normalized variables. But we want it on the reverse. We want lighter shade for smaller values and darker shade for larger values. So what we need to do is to first let's get the range. So we want gray 1, okay, and then gray 2, then gray 3, and so on. So what we need is a paste gray, right? And then we have 1 through 99. And then we have our separate is to quotation marks with nothing in between. Okay, so okay, close parenthesis. Okay, so now you have the dendrogram, but we want the colors to be on the reverse. So what we need to do is to say reverse. There's a function for that, and now it'll get reversed. Okay. And then we can give a title, say main equal to heat map of normalized values. Okay, and I need only one M there. Okay, so that's our heat map.